So what I'm trying to say is, let's say, okay, let's say that I draw a shape, okay, for example, a very complicated shape, okay, maybe not too complicated, but something like this. Oh, sorry, this is not good. Okay, let's say a parallelogram, okay, a parallelogram, and maybe I add this. Sorry, what is it? This is something like a parallelogram, and I add this into it. Okay, something like this. Okay, this shape, for example, and they want you to find the centroid. Okay, I'm not using any numbers, by the way. Just I want to show you how you can break it down to a very simple shape. Again, the first objective that I've been telling actually is that I want you to think in three shapes only: rectangle, okay, triangle, right angle triangle specifically, and circle. Okay, if got circle, but most of the time I just want you to think in rectangle and right angle triangle. How can we split the shape into small rectangles and small triangles? Then we can easily solve for centroid. Okay, so the thing is, if you look at this shape here, this blue shape, what I can do first, I can easily draw a line here. Okay, once I draw this line, so this first shape here is clearly a right angle triangle. Can you guys see the right angle triangle I just drew on the complicated shape?
Yes.
Okay, so this is shape number one. Now the next thing, what's the next objective that we should do? The next thing we could do is, I see that this is a basic, this can be a right angle triangle also, right? This can be a right angle triangle, so this shape here. Okay, so this is shape number 2. Are you guys following so far? How is this shape number 2? Because here is like a slanted edge, but I took the advantage that from here to here also can look like a triangle, a right angle triangle. That's why I split it. Can you guys follow?
Yes, sir.
Okay,
Yeah.
great.
Yeah.
Then the next thing is that if you guys notice that there's two straight edges, one is from here, another is from here, I can connect this straight edge, okay, from this part to here. I just connect it. Then you can see there is another rectangle. Okay, this is rectangle right here. This rectangle right here is rectangle number 3. Okay, can you guys see rectangle number 3? Can you follow?
Sure.
Okay, then what's left? We have this part. Now this part looks like a rectangle, right? This is actually a rectangle. So this is rectangle number 4. Okay, so why I did this is that I split our very complicated shape into 4 simple shapes. Number 1 and number 2 are triangles, right angle triangles, and number 3 and number 4 are rectangles. So you see our 1 and 2 become right angle triangles, right? It becomes right angle triangle. And our number 3 and 4 becomes rectangle. Okay, becomes rectangles. Now why I did this is because later when you want to find the area of the shape, okay, it's much easier to find the area of a rectangle and a triangle triangle, right? You guys know the formula for right angle triangle is half times base times height. And for and for rectangle it's just simply length times breadth. Correct or not, guys? Guys, hello?
Yes, Yes. sir.
Okay, so we can easily find the area of the smaller shapes. That's the whole point of splitting it. So basically the area of one is just simply half times base times height. For number 2 also is just half times base times height. Number 3 is just simply length times breadth. Okay, this B is breadth. Yeah, don't confuse the B for triangle here. It's different. Don't be confused. And this is just length times breadth. Okay, so it becomes much easier if you were to find the area for this particular complicated shape, can you find the area immediately without any formula? What do you guys think? Previously, before I did the splitting, can you find the area directly or not?
No.
No, right? But once I did the splitting, once I split into a bunch of right angle triangles and rectangles, it actually made it a lot easier for us, right? It made it easier for us to find the area, right, for this particular complicated shape that I highlighted in blue. Okay, so that's the reason why we do it. Besides that also, it's easy for you to find the x tilde and y tilde actually for the components. Because for shape number 1, the x tilde is very easy. It's just simply 2/3 of the base, right? You guys can follow, right? So far for x tilde for shape number 1 is just located at 2/3 of the base of the triangle. Guys?
Yes, sir.
Okay. And then for the y tilde, it is just simply 1/3 from the right angle edge. Is just simply 1/3 from the height of the triangle itself. Okay, so you know that's basically for triangle number 1. Now for triangle number 2, okay, I know it looks a little bit tricky because now it's inverted a bit, right? It's an inverted looking triangle, but you don't have to be afraid at all. It's very simple. To find the x tilde for such a shape is just you go all the way here. So this is some arbitrary x value, okay, before it touches the triangle. Then from the right angle edge to here is just 1/3 of the triangle's base. It's just 1/3 of the triangle's base. So this x plus 1/3 of the triangle's base. So for x at 2, the x tilde at 2 is just this x value here, which goes from the origin to this part, and then plus with 1/3 of the triangle's base. Okay, this triangle's base, yeah, triangle 2, don't be confused. Triangle's base, basically that's your x tilde. Can you guys follow so far? Guys, hello?
Yes, sir.
Okay, great. And your y tilde for triangle number 2 is what? Is basically this particular breadth, okay, of triangle number 4. Okay, this breadth from triangle number 4, I put a 4 just to make it clear. And basically it's gonna be 2/3 of this triangle's height. Okay, 2/3 of triangle number 2's height. So it's gonna be plus 2/3 of the height of triangle 2. Okay, is it clear or not, guys, so far? Guys, hello?
Yes, sir.
Okay, so once you find your x tilde, y tilde 2, I think for 3 and 4 is pretty straightforward. I don't have to explain it. And then of course what you do is that you tabulate it, alright, with each section. So section 1, section 2, section 3, section 4. Then you have your area, you have your x tilde, y tilde, z tilde. Okay, then you can easily find your x tilde a, your y tilde a. You multiply basically x tilde with the area itself, okay, and so on and so forth. Okay, and then you can easily find your summation a, summation x tilde, summation y tilde a, and summation not z, sorry, there's no z actually because it's 2D. Sorry, why did I put z? My mistake, sorry guys. Yeah, it's your x and y only, okay? And then you can easily find your x bar and y bar very easily. You know, you remember your x bar is just simply summation of x tilde a over summation of a, and your y bar is just summation of y tilde a over summation of ya. Okay, is it clear, guys, so far? Actually, that's why we split a complicated shape into a simple rectangle and simple triangle, right angle triangle. Can all of you follow so far? Guys, hello?
Yes, sir.
So everybody can follow, yeah? There's hopefully gonna be no problems. It all depends on how you section the shape. And normally this can be one example in your final exam. They can give something like this. Okay, now Let's say for example I draw the same shape. I'm gonna erase this if you guys don't mind. Okay, I can show you there's another way also to section this, but the same exact shape that we discussed. Okay, it'll be very quick. I'm sorry for taking a very long time actually. I was hoping to end it earlier, but I guess it's quite an important discussion also. Okay, great. So let's go back to our same shape again. Yeah, I'm gonna draw the same shape, exactly the same shape. Gonna be in this. Okay. Okay, great. So previously we sectioned it like this, right? We sectioned it into a right angle triangle here, another triangle here, and two rectangle, right? So two rectangle and two triangles. Now, what if I told you there's a different way to section the shape? Maybe you can section it to a single rectangle also. Okay, I know I'm gonna a little bit cause a problem here. A single rectangle also. Okay, so meaning to say that if I use orange, that this is gonna be one single rectangle. Okay, one single rectangle. Let me shade this in blue, yeah, because our actual region of interest is here. Okay. Okay. This is one single rectangle. So you see this region here is basically a hole. So this is a hole. This is a hole. Okay. The orange region here is basically the entire rectangle. Okay. And we have how many holes? We have one hole and two holes, right? But this is a trapezium. Why not I simplify this? I make it into another, what do you call it? Another hole. So we have three holes. Okay, so we have three holes. Okay, hole 1, hole 2, hole 3. And the entire thing is a rectangle. Okay, so rectangle, I don't call it rectangle, I call it rectangle. So this is one large rectangle and we cut three holes. Hole 1, hole 2 and hole 3, we get our desired shape. So, you know, instead of just now what we did, we are actually going to have a hole shape and we're going to subtract with the holes. Okay, we're going to subtract with the holes itself. So meaning to say we find the area of the rectangle, which is very simple. You already know is just length times breadth. Then for hole 1, it's a simple triangle, but it's a hole, yeah? That means to say the area is negative. So negative half times base times height. Similarly for hole 2 is just negative half times base times height. And hole 3 is just negative half times base times height. Okay? So we did it like this. So that means the summation of area altogether is basically the rectangle area, which is just in orange. So I'm going to put rectangle area as orange color A. Plus, or you can put minus if you want, minus A1, which is basically the area of hole 1, minus A2, area of hole 2, and minus A3, area of hole 3. Okay, that's your summation of area. Then how about your x tilde? Okay, x tilde for the whole 1 actually is just simple. It's just 1/3 of the base, the triangle base. Which triangle base? This triangle base. Just 1/3 of it, because we're going from the right angle edge to here. It's 1/3 only. Okay, and here this is basically gonna be 1/3 of the base 1. Okay, for how about for x tilde for hole 2? Okay, very simple. We have this arbitrary value x that starts from the origin to the start of the triangle, the hole right away, and we plus 2/3. Okay, because the center is here, so 2/3 of the base. So your x tilde for triangle 2 is just x plus 2/3 of the base. And for this one is a rectangle, it is just some arbitrary x value. This x value will change here because it's going to go through the whole base. It's going to go all the way here before the start of the rectangle and half of the base of the rectangle itself. So it's just simply some arbitrary x value. Okay, I'll call this x prime, whatever, because it's this whole thing we consider as x prime. Okay, plus half of the base. Okay, is it clear or not so far, guys, for the x tilde? Can you guys follow?
Clear.
Okay. So
Yes.
once you found the x tilde for all of them, and rectangle is very easy. Rectangle is half of this base only, like basic, right? X tilde for rectangle just b over 2. And y tilde also similar steps. Okay, if it's for this particular triangle, okay, rectangle, a triangle hole is just 2/3 of the height. And then I think I leave the rest. Okay, I think the rest you guys should be able to figure it out. For this one is also, this one is just simply this part. Okay, this part, by the way, plus 1/3 of the height of triangle 2. Okay, in this case hole 2. Okay, that's your y tilde. And for hole 3, it is just simply this particular region. Okay, this part of the region plus half of the breadth. Okay, for y tilde. For the rectangle hole 3, it's just simply whatever this y value is, which is it'll be given to you, don't worry about it, plus half of the breadth. Okay, and then obviously you do your usual. You find the x tilde times a for all of this, the rectangle for hole 1, hole 2, and hole 3. And for the hole is going to be negative, yeah, because the area is negative, right, since it's a hole. So your x tilde a also be negative as well. Similarly, also for a y tilde a, for all of them you find, rectangle will be normal, but for the holes it'll be negative because again your area is negative. So you do the summation of x tilde a, okay, you do a summation for the y tilde a, okay, then you divide with your summation of area. Okay, so this is a different way to section it. If you want to section it like this also, guys, there's no problem, it's also fine. Okay, you can also have holes, but just don't forget that if you're dealing with holes, make sure you subtract, yeah, for the area. They have negative area. Okay, so is that clear that there are two ways to sectioning a complicated shape? Guys,
Yes, sir.
okay, so when you section the shapes, just remember only two things. You can either section it to a rectangle or a right angle triangle or circle, but usually these two are the most prominent ones lah. Circle is like rarely you'll see. Like this example was not a circle example, right? There was no circles to section, right? So yeah, this rectangle or triangle. And how you want to section it is up to you completely. Both methods I shown here will obviously get you the same x bar and y bar. They will not change. That's the very cool part. Whichever method of sectioning you want to use, either you want to break down the shape into small rectangles and triangles, or you draw one big shape and then you subtract with the missing shape or the holes. It's completely fine. Whichever method you want to section the shape, it's up to you. It's your own creativity. You just do the one that's the easiest for you. Okay, and it depends on the shape. That's why I say you need to practice a little bit, guys, so that you can make your life easier. Sometimes doing the second method is easier. You just do one big shape and minus the holes, or you break the shape into smaller rectangle and triangle if that's easy for you. Okay, end of the day you'll get the same x bar and y bar. Clear?
Yeah, clear.
Oh, okay, great. If any question, you can also ask again WhatsApp, no problem. Don't hesitate. And I think that's about it for this tutorial. Sorry for taking 30 minutes extra. I didn't plan to do so, but yeah, that's what it is. So tomorrow, inshallah, we'll be discussing on chapter 7. Are you guys okay with this timing, 8:30 to 9:30, or you prefer a little bit later or a little bit earlier? Can you guys let me know? A little bit early is a bit difficult because I am not going to be available tomorrow. Like in the evening, I'll be outside. I'll not be at home. I'll not be able to help. So, are you okay with tomorrow? Maybe let's say 9:30 to 10:30, or what? What do you guys think? I need to hear your opinions actually.
This time is fine.
Sorry, what is it?
Today's timing was fine. for
Today's
me at
timing
least.
is okay. How about tomorrow actually? You want to have the same?
Uh, For me, yes, I think the same time would be fine.
Okay.
But I'm not sure about the rest.
How about the rest? What do the rest think? Actually, is it okay if we proceed the same timing? I'll try to be home before 8:30 and start the class. But if I do end up a bit late, maybe at 9 probably I'll start. I'll update you guys by tomorrow actually, because it's gonna be quite a busy day for me tomorrow. Maybe on chapter 7, okay? I think on internal forces, because some of your classmates were asking for it. Although I think chapter 7 is probably one of the slightly easier chapters, but again, you know, I'll do my best to help you guys out with this, okay? The rest, are you okay with like 8:30 or 9 p.m.? If let's say I start a little bit late, like 9 p.m., is it okay?
I'm okay to sit.
Okay.
Yes, sir. Fine.
Alright, great. Alhamdulillah. So thank you guys once again for joining and having the patience to listen to my explanation. I wish you all the best for your final examination. I think it's on 31st. You also have one on next week, right, Mats?